Historically, electricity has been taught to students as being caused by the movement of free electrons in a conductor. This worked well for DC batteries and electrochemical energy, but when considering AC electricity, the concept is inadequate, as physicists know that electrons have mass and require huge energies to accelerate them to the speed of light. A submarine cable, however, laid under the Atlantic, can transmit AC vibrations at nearly the speed of light with very little loss of energy, thus can have nothing to do with electron particles. The vibrations must therefore be contained in the magnetic energy field, or magnoflux, which moves through the spare holes in the conductors. Microwave ovens. If we were to strip a sample down, it would reveal that there is a large high voltage transformer which sets up a voltage at right angles to the current flow. If the cavity inside is tuned correctly, then the magnoflux on Now, consider an induction motor. It only has one primary winding. There's no voltage or current electron connection between anything else on this motor apart from the primary winding, which when unenergized is not magnetic. No magnetism there. However, at switch on, the hum demonstrates the linking of the windings through the 3D magnetic field. There it goes, you see the compass move, and now we've got a lot of magnetism there. The compass also sensed that movement at the start, as you probably noticed. And if we move things around now, we can still see, of course, that the compass moves as this does that. But it's nothing to do with electrons, but it's all to do with magnetic energy. Sorry, that's the voltmeter. Now, if we lock the rotor of this transformer like this, then the hum comes on and the current goes up slightly. And if we use a clip-on ammeter on the secondary, on here, like that, we notice that we've got about 180 amps flowing through the circuit, which means that a lock rotor induction motor is the same as a transformer, but both of them are working on the magnoflux energy. The transformer takes in the volts and the amps on the primary, and it's able to put them into the secondary only through the magnoflux. Again, there's no wire connecting the two, and it's totally to do with the energy, magnoflux energy. Okay, Fleming's left-hand rule states correctly that the magnetic field needs to be at right angles to the voltage amperage field, and then mechanical momentum would appear magically in the third dimension using the rotating fingers of the left-hand rule. As you can see there is quite correct. The only improvement we can make is that it's magnoflux or magnetic energy that is in the third field, not just mechanical energy. Magnetic mechanical energy is the correct thing. So the next problem we have is that mathematicians tried to simplify the equation for power into voltage times amps times cos phi, which then made it appear that the voltage and the current had to be in phase, although we know from the left-hand rule that couldn't be correct. This resulted in the electrostatic volts and amps being in the same phase, then some sort of mechanical momentum at right angles, and then the magnets somewhere or other up there. That is unsatisfactory. We need to get back to the basics, and the basic power is magnoflux, is a magnetic energy field which is formed at right angles by the voltage and amp fields. This presentation demonstrates an alternative view of electricity as a three-dimensional electromagnetic field of unit magnoflux energy, which is also the essence of microwave and light energy, derived from a quadratic volt-amp field.